So I want to talk about the tangential velocity of stars. And so let me explain what this is. We know that when you look out into space and see stars, they look like they move. So that's proper motion. All right. The symbol for proper motion is a lowercase Greek mu. Okay, so it's in the right-hand column right here. And so these are the proper motions. The biggest number is going to be the fastest moving star with the biggest proper motion, and the smallest number on that table will be the one with the lowest motion. Now, the proper motion is how fast the star looks like it's going side to side. And it turns out how fast it really is going side to side is related to how fast it looks. And so you know that if you look up and see an airplane go by, it doesn't look like it's going very fast if you're way on the ground. If it's flying low, it looks like it's going faster. If it's high up, it doesn't look like it's going as fast. So the proper motion, the actual speed, the velocity of the aircraft depends on how fast it looks like it's moving and how far away it is from you. So in our diagram over here, we've got the star moving to the side. That's the tangential velocity, or this diagram borrowed actually from Wikipedia, called transverse velocity. Mu is the proper motion, and then d is the distance. So the relationship is that the actual speed is given by mu times d. So it's a really simple equation. You just multiply the proper motion times the distance. Now, that's measuring distance in parsecs. So the distance has to be in parsecs. Well, you remember the way we found the d in parsecs is 1 over the parallax. And so if you do this, that gives you AU per year. 1 AU is how far Earth is from the sun. So it tells you how many Earth-Sun distances per year. Sometimes what you want to know, though, is how fast is it moving in kilometers per second. Now, we can go through a whole bunch of mathematical analysis to convert units and everything, or we can just multiply 4.74. So if you multiply the AU per year, which is just mu times d, times 4.74, you get the answer in kilometers per second. So let's do an example here. Let's look at the star Psi Ursa Majoris. So the parallax is 0.147, and the proper motion is 0.075. And I want to know how fast is the star moving side to side. So you know that the speed moving side to side is mu times d. But we need to know d. D is 1 divided by parallax. Well, I said the parallax was 0.147, so the distance is going to be 6.80 parsecs. So the velocity to the side is going to be mu, and we said that mu was 0.075 from the table, and you multiply times 6.80 parsecs. And so the velocity side to side is 0.510 AU per year. So that is how fast that star appears to be moving side to side, is the proper motion. And we can include the effect of the distance. It means it's going about half an AU a year. So remember, half an AU, that's half the distance between the Earth and the Sun per year to the side. And that's the star Psi Ursa Majoris. Now let's look at another star. Okay, so let's look at the star Procyon. And so Procyon has a parallax of 0.285 and has a proper motion of 1.248. So for Procyon, I want to know how fast is it going. So we know, again, the velocity is mu times d. We know that d is 1 over the parallax, so that's going to be 1 divided by 0.285, so the distance is going to be 3.51 parsecs. And so the velocity side to side, the tangential velocity, is going to be mu, and mu was 1.248 times the 3.51 parsecs. And so that means the velocity is going to be 4.38 AU per year. Well, that's huge. That means that the star Procyon is moving through space relative to the sun. It's going side to side over 4 AU, more than 4 times the Earth-Sun distance per year. In fact, 4.38 AU is about the distance between Earth's orbit and Jupiter's orbit, and it covers that entire distance in every year just going to the side. So that's a pretty big deal there. Well, the velocity, if I want to multiply 4.74 times mu d, now 4.74 mu times d is 4.38 AU per year. We just figured that out. So that means the velocity is going to be 20.8 kilometers per second. So that means that star is moving side to side almost 21 kilometers every second. Okay, in later lectures, we'll figure out how to figure out how fast it's coming towards us or away from us. But this is the basic way that you would calculate the tangential velocity.